Friends, welcome to online lecture series of Engineering Mathematics 2. Today we will continue with gamma function. Last lecture we already saw the definition of your gamma function. So we know the value of your integration runs from 0 to infinity e raised to minus x raised to n dx is gamma of your n plus 1, where your n is greater than 0. This is the definition of your gamma function. In this definition, we observe that the exponential function whose index is minus times variable of your integration multiplied to this e raised to minus x raised to n, it means variable raised to n. If the integration in which the product of your exponential function and function x raised to n, instead of these two terms, another functions are exist. So according to definition of your gamma function, we have to convert example in the gamma function definition. For that, we will see some basic type of your gamma function, which is reduced to gamma function. So here, the first example, the first type is that if the integration runs from 0 to infinity e raised to minus x raised to n dx, we have to just solve this particular integration. But this example is not solvable because we don't know the value of your n. Suppose the n is greater than, we define n is greater than suppose 0. But we actually don't know n is my positive real number or a positive integer. Means it is a fraction or some real number, we actually don't know. How to find the solution? We have to convert such an example in terms of gamma function. For that, we have to assume the given integration is equal to, we assume here the value of your integration e raised to minus x raised to n dx, limit goes from 0 to infinity equal to I. When we compare this example with our gamma function definition, it is clear-cut mentioned that the index of your exponential function is minus times x raised to n instead of x. In the gamma function, it is e raised to x. But in this example, the exponential function index is minus x, but this x index is 1. The gamma function, what we say, the index of your x is 1. So we can express our gamma function definition in the form of e raised to minus x raised to 1, or by default we cannot write 1. So we have to put the value of your this x raised to n is equal to some variable or some parameter. So we will just assume this minus x raised to n is equal to t, and we require the value of your x. So taking 1 upon nth power on both the sides, so x is equal to t raised to 1 upon n. Then we have to differentiate on both the sides. The derivative of your x becomes dx, and the derivative of your t is 1 upon n, because we have to use the formula x raised to n, and x raised to n formula is, see here, this is suppose x raised to n x raised to n can be expressed n times x raised to n minus 1, x raised to n minus 1. So with the help of this formula, the index of your t is 1 upon n, so it becomes 1 upon n. Index of your t reduced by 1, 1 upon n minus 1, and the derivative of your d, so derivative of your t is dt. When we change the limit of your integration, because we are changing the variable of your integration from x to t. For that, we have to change the limit of your integration. When the value of your x equal to 0, the limit of your t also goes to 0. When x equal to infinity, the value of your t goes to infinity. We can find this particular limit by just putting the value of your x equal to 0 and t equal to infinity, and this x to n is equal to t. We get the value of your t from 0 to infinity. So we have to convert the given example into the new variable, that is t. This is our given example, and we know that the integration limit is same, 0 to infinity, so it remains as it is, 0 to infinity. Then this e raised to minus x raised to n, we have to replace the value for x raised to n is equal to t. We are replacing the value for e raised to minus t here. So again, the value for dx, the dx equal to 1 upon n, t raised to 1 upon n minus 1 dt. So we are replacing the value of your, that is a dx, 1 upon n t times t raised to 1 upon n minus 1 dt. Here 1 upon n is a constant. We are taking the constant outside integration. So 1 upon n outside of integration. So we got 1 upon n integration 0 to infinity e raised to minus t, t raised to 1 upon n minus 1. So with the help of definition, we can find the solution of this particular terms. When we compare this example with the definition, the index of your exponential function is minus t. The index of your t is n minus 1. Here, when we compare your n minus 1 with 1 upon n minus 1, we have to add 1 in the index of your t. So the final solution of such an example is 1 upon n. We can say that this is 1 by n minus 1 is the index of your 1 upon n. Then we have to add 1 in that. We are added 1 in that. We have to close the bracket. So this is the actual terms by using the definition. This plus 1 minus 1 get cancelled. So we get a final solution. 1 upon n outside integration remains as it is, and 1 and plus 1 get cancelled. So we get a solution, that is a 1 upon n gamma of 1 upon. In this way, we can find the solution of e raised to minus x raised to n dx, where limit goes from 0 to infinity, n which is greater than 0, value of that particular term is equal to this much. So we will define the property here. With the help of this property, we can find the solution. We will just define the property here. What is the property? Integration of this is equal to what? 1 upon n gamma of n, whereby n is greater than 0. This is a standard property of this particular terms. When we change the value of your n, instead of n, we suppose we choose 8, 10, 9, 10, 100, 1 upon 2, 1 upon 15. We have to just make the simplification. For that, we will see the example. But when we change the value of your x equal to index of your x is in terms of 8, we have to assume the given term as equal to index I. Then we have to put the x to 8 is equal to some parameter. So putting the value for x to 8 is equal to t. Then taking 1 upon 8 power on both the sides. So x is equal to t raised to 1 upon 8. Taking derivative on both the sides, the derivative of your x becomes tx, and the derivative of your t raised to 1 upon 8 becomes 1 upon 8, t raised to 1 upon 8 minus 1 dt. And again, the limit of your integration, there is no change. When x equal to 0, t equal to 0, x equal to infinity, t equal to infinity. Replacing the example with the new parameter t, this is the given example, and we have to change the value for x to 8 is equal to t. We are putting the value for x to 8 is equal to t. Replacing the value for dx, it is 1 upon 8, t raised to 1 upon 8 minus 1 dt. 1 upon 8 constant outside integration. Then we have to just compare with a standard definition. then we get the value where n is equal to 1 upon 8. So the final solution of this example is I equal to 1 upon 8, gamma of 1 upon 8. In similar way, we can find the solution when we change the value of your n. For that, we will just take another example. If the n is in terms of fraction, the last example, the value for n is equal to 8. Here we will say that the value for n is equal to 1 by 4. Again, we have to assume this integration is equal to I. So we say that consider I is equal to this one. Then we have to just put the value of your x raised to 1 by 4 is equal to t. Then taking 4th power on both the sides. So x raised to 4 is equal x raised to 1 by 4 raised to 4. It becomes x and index of your t becomes 4. Taking the derivative on both the sides, derivative of your x becomes dx. The derivative of your t raised to 4 times t cube dt. And the limit of your integration is same. When x equal to 0, t equal to 0, x equal to infinity, t equal to infinity. Just changing the value, integration's limit and the entire expression e raised to minus x raised to 1 by 4. We know that the value of your x raised to 1 by 4 is equal to t. So we're replacing the value of that. And again, dx is nothing but my 4 times t cube dt. Again, 4 is a constant chosen as a constant outside your integration. And according to definition, when we compare, the index of your t is 3. So gamma of 3 plus 1 is my solution. Means we are getting 4 is a constant, 3 plus 1 is my gamma of 4, and we know that gamma of 4 is nothing but 3 factorial. 3 factorial means 6, and 6 into 4 is my 24 is my solution, or we simply say that it is 4 factorial. It is 4 factorial. In this way, we can find the solution of different examples. Here 2 examples are defined and we have to use the shortcut here. We have to use this standard property. With the help of this property, we can just find the solution by comparing the value of your n. When we compare the value for n is equal to 15. So what n is equal to 15 here. By this property, if the integration goes from 0 to infinity, e raised to minus x raised to n dx, the solution is 1 upon n and gamma of 1 upon n. When we compare example first with this standard property, the value for n is equal to 15. So the answer is 1 upon 15 into 1 upon 15's gamma. If in second example, if the integration whose limit is 0 to infinity, in that e raised to minus x whose index is 1 upon 5, and we have to take the reciprocal of this 1 upon 5, it is 5, and 5 into gamma of 5 is my the solution of this example according to this particular property. And we know that gamma of 5 is equal to 4 factorial. 4 factorial is 24. 24 into 5 is equal to 120. 120 means it is my 5 factorial. So we can find the solution in this. We will stop here. We will see the next type on next lecture. Thank you.